In section 8.4, we look at quadratic functions and their graphs. So a quadratic function is a function of the form f of x equals ax squared plus bx plus c. So a quadratic function is a second degree polynomial function, and the leading coefficient a cannot be 0. This is what we define to be a quadratic function. Now, this quadratic function can be put into what is called standard form, and the standard form of a quadratic function looks a little bit different. It is this equation here. F of x equals a times the quantity x minus h to the second power plus k. The graph of a quadratic function is what we call a parabola, and I am pretty sure most of you have heard of a parabola before. A parabola is this sort of U-shaped graph that we will talk about here in just a minute. And it has a vertex at the point hk, and the h and k here are referring to the numbers h and k here. Do notice, though, that this is negative h and this is positive h, and so that kind of matters. We'll come back and talk about that. If the number a is a positive number, then the parabola is going to open upward, like you see here. If a is a negative number, it will open downward. And the line x equals h is what we call the axis of symmetry. So a parabola is this sort of U-shaped graph here. It's actually more like a soft V-shaped graph. And this bottom point here is what we call the vertex. It's kind of like the center or the middle of the parabola, but we call it the vertex. And these are the coordinates h and k. In general, you would have coordinates h and k here. Now, in this case, this would be a situation where a is positive. So let me just note that here. In this case, a would be positive because it does open upward. And the axis of symmetry is the vertical line, x equals h. And if you were to graph that line, x equals h is this vertical line right here. And we call this the axis of symmetry because what this line does is it takes this parabola and it cuts it in half into two symmetrical halves. Okay, let's take a look at some examples. So in our first example here, we want to graph the parabola or the quadratic function f of x equals x minus 3 quantity squared plus 2. The coefficient in front of the parentheses here is 1. This is our value of a. And of course 1 is positive, and that means that our parabola should open up. Now, anytime you graph a quadratic function, you have to have the vertex of the parabola. And the way we get the vertex is we look at these two numbers here. And what's really important is when you're finding the x coordinate, you need to take the opposite of this number. Remember, this is x minus h. So that means h is positive 3. So the vertex is going to be at positive 3. And then the y coordinate of the vertex is this number here, and that is positive 2. So the vertex of this parabola is at positive 3, positive 2. That is this point right here. I'll put a little v here, which stands for vertex. We know the parabola is going to open up, so we know it's going to have some kind of a shape like this. Okay, but we don't just want to graph anything. We want to graph it accurately. So what we need to do is make a small table of values, and we don't need a lot of points, but we need a few points because it's not linear. It's not a straight line, so we need to get a few points. We already know 1 point on this parabola is the point 3, 2, because this is our vertex. Now, what I need to do is get a few other points. So because the vertex occurs over here at x equals 3, I'm going to plug in two values of x to the left of 3, which would be 2 and 1, and two values to the right of 3, which would be 4 and 5. So in our table here, we're going to plug in the values 1, 2, 4, and 5, and those values go into the function. Now, I won't show the work for all of this, but let me show you f of 1. So when you plug in 1 into your function, you're going to get 1 minus 3 to the second power plus 2. This is negative 2 squared plus 2, which is 4 plus 2, which is equal to 6. So when you plug in 1, you get 6. Now, when you plug in 2, it turns out that you're going to get 3. When you plug in 4, you will also get 3. And when you plug in 5, you will get 6. And so you might want to verify those numbers to make sure that you understand where they are coming from. But once I have those points, we can start to really see the shape of this curve. So again, we have the point 1, 6, which is this point here. We have the point 2, 3. Of course, we already have the vertex 3, 2. And then we have 4, 3. And finally, we have 5, 6. And you can see that when you graph this, you get this sort of soft V-shaped graph. Okay, and this is our quadratic function. Now, a couple of little notes here. So the vertex occurred at the point 3, 2. The axis of symmetry occurs at x equals 3. And again, the axis of symmetry is this vertical line right here. You don't necessarily have to graph the axis of symmetry, but you need to be familiar with it. And we can see the parabola opens upward. Right? A couple of other small details to note here. The domain of this function is minus infinity to infinity. In other words, you can plug in any value of x that you want. But the range of this function is not all real numbers. The smallest y value that you get is this y value right here, and that's y equals 2. Every other y value on this graph is higher than 2. So the range of your function would be from 2 to infinity. Okay, let's try a couple more. So let's graph this next quadratic function. So again, first of all, I'm just going to make note of the fact that a, in this case, is negative 2, which is less than 0. And that means that this parabola should open down. Okay. The vertex of this parabola, again, you need to look at these two numbers. And for this number here, you need to take the opposite. So the vertex is going to occur at negative 1, positive 2. Negative 1, positive 2 is located here. And so there is our vertex. And it should be opening down from this point. So something like this. Okay? But to get a more precise graph, we are going to make a table of values here of some x's and some y's. And the first value I'm going to put in the table is the value of the vertex, which is x equals negative 1, y equals 2. Now, the reason I do that is because, once again, if you look on the x-axis here, here's where x equals negative 1. I'm going to pick two values to the left of negative 1, which would be negative 3 and negative 2. And I'll also pick two values to the right of negative 1, which will be 0 and positive 1. And then you need to take all four of these values and plug them into your function to find the corresponding y values. Now again, to save time in the lecture video here, I'm just going to plug in -3. When you put -3 into the function here, you will get -2 times the quantity, -3 plus 1 squared, plus 2. This is -2 times the quantity, -2 squared, plus 2. Lots of 2's here. This is -2 times, -2 squared is 4 plus 2, and this is -8 plus 2, which is -6. So when we plug in -3 for x, we get y equals -6. Okay? When you plug in -2 for x, you should find y to be 0. When you plug in 0 for x, you will find that y is also 0. And when you plug in 1 for x, you will find that y is -6. And once again, once I have these points here, all I need to do is take these points and graph them and then sketch the curve. So -3, -6 is this point here. -2, 0 is this point. 0, 0, of course, is the origin. And 1, -6 is down here. And so the graph of this function looks something like this. Okay? So notice that it does open down, which is what we expected. We can see that it has a vertex at the point -1, 2. Its axis of symmetry is the line x equals -1, and that is this vertical line right here. Its domain is all real numbers, and its range, the highest value in its range, the highest y value is y equals 2. So all the other y values are below that, so its range is -infinity up to 2. All right? So for our next example, we're going to look at graphing quadratic functions when they are not written in standard form, but rather they are written in the original form that I gave you. So we're comparing this form versus the other form, which was this one. So we already know what to do if it's in this form. When it's in the standard form, it's easy to find the vertex, right? We just did 2 examples like that. But what do we do when it's in this form? Well, there's 2 options. The first option is you can take this form and you can convert it into the other form. And the way you convert it is by completing the square. So remember that, completing the square. So what we can do here, and it's a little bit different than the completing the square that we did earlier, but what we can do here to complete the square, first of all, you need to make sure you have a 1 here, which we do, so we are good to go. So we have x squared minus 6x. We're going to complete the square with a number here, and then we have a plus 5 here. Okay, that just gets brought down. So when you complete the square, remember the process is that you take the middle number, which is -6, you divide it by 2, and you square it. And if you do the math there, this is 9. So the number we need to add here to complete the square is 9. But if I add 9 and I don't do anything else, I've changed the problem. So what I'm going to do over here on the other side of the 5 is I'm going to subtract 9, because this 9 and this -9 here, those cancel each other out. And what I mean by that is we haven't changed the equation. Now, of course, we're not going to cancel them, because if you cancel, you just get what you started with. Instead, what we're going to do is we're going to regroup this problem, as x squared minus 6x plus 9. This is now our perfect square. And then 5 minus 9 is negative 4. And now what we can do is we can factor this. So it's going to be x minus 3 quantity squared minus 4. And you can see now we have converted our original equation, which was in this form. We converted it into this equation, which is in this more useful form. And so from here, you would just follow the same procedure as we did in the last two examples. The vertex here is positive 3, negative 4. So on the graph here, the vertex is this point right here. And then you could make a table of values. And I'm going to do this in a sort of abridged fashion here. But here's our vertex, 3, negative 4. And we need to pick some other values of x to the left of 3, which would be 2 and 1, and to the right of 3, which would be 4 and 5. And if you plug those values into your function, and you can plug them in either here or here, it doesn't matter, you will get y equals 0 for this one, y equals negative 3 here, negative 3 here, and 0 here. And now if we just graph those points, we have 1, 0, 2, negative 3, the vertex, and then we have 4, negative 3, and finally 5, 0. And you can see that we have our parabola here. Right? And you can answer all the same questions. So, of course, the vertex is 3, negative 4. The axis of symmetry is x equals 3. And again, that is this line right here. And the domain, well, the domain would be all real numbers. And the range would be all numbers starting from negative 4 and going to infinity. So the point is, once you convert the equation into the standard form, it's all the usual stuff that we did in the previous two problems. Okay? So this is one method for doing this. We can complete the square. This is not usually everyone's favorite method. Let's take a look at something else. We do have an alternative method for doing this. So once again, if you have a quadratic function in this form, if you don't want to complete the square, and most students don't, you can use a formula to find the vertex. And so the vertex formula is x equals negative b divided by 2a, and then the y-coordinate you get by plugging the x-coordinate into the function. So as an example of this, let me just use the example that we just completed in example number 3. Now, we found the vertex for this by completing the square, but we can also find the vertex by using this formula. And so remember, the vertex formula is x equals negative b divided by 2a, and in this problem, this is negative, and then b is negative 6, divided by 2 times a, and a is 1, and this is 6 divided by 2, which is 3. So the x-coordinate of the vertex is 3. And then once you have that, the y-coordinate you get by plugging this x-coordinate into the function. So the y-coordinate is simply f of 3, which is 3 squared minus 6 times 3 plus 5, which is 9 minus 18 plus 5, which, when you do the math here, is negative 4. And so the y-coordinate of the vertex is negative 4, and that means that the overall coordinates of the vertex is 3, negative 4. And if you compare that to the previous slide, which I will go back to now, you can see that's the same vertex that we got back here, 3, -4, okay? So you can either complete the square or you can use this new method. They both work for giving you the vertex. Now, of course, I'm not going to finish this problem. I'm not going to graph it because we already did that on the previous slide. Now, unfortunately, sometimes you will be asked to complete the square and you will need to know that method. But the vertex formula does give you an alternative for when they allow you to use other methods. Let's look at one more example. Okay, so I would like to graph this quadratic equation, or quadratic function, I should say. And I'm going to do it two ways. I'm going to find the vertex by completing the square, and then I'll find the vertex by using the vertex formula, which of course will be easier. So first, let's look at completing the square. So first of all, to complete the square, you need to remember that the leading coefficient has to be a 1 to complete the square. Now, what I'm going to do, since I don't have a 1 there, is I'm going to factor a 3 out of the first two terms. So if we pull a 3 out of the first two terms, we get x squared minus 4x. And then I'm going to close the parentheses, leaving a space for completing the square right here. And then we do have plus 5, which comes down, okay? And now on the inside of those parentheses, I do have a 1 there. That's what I wanted. So now to complete the square here, I'm going to take the middle number, which is -4, divide it by 2, and square it. And this is -2 squared, which is 4. And that means the magic number for completing the square here is I need to add 4. Okay? Now, once you add something, you've changed the entire function. So out here, we need to compensate for the fact that we added 4 here. So most students will say, oh, well then that means we need to subtract 4. That way, these will cancel. Well, do they cancel? Well, yes, 4 and -4 cancel, but here's the problem. The problem is this 3 here gets multiplied to 4, and 3 times 4 is actually positive 12. So if I really want to cancel the 4 that I added here, see, I really didn't add 4, because that 3 gets multiplied to 4, so it's really like adding 12. So what I really need to subtract over here is I need to subtract 12 to cancel that. Now that can be really confusing for people, especially in the beginning. But let me go ahead and move on. So we have f of x. I'm going to bring the 3 down. Now this is going to factor. That's going to be x minus 2 quantity to the second power. And then 5 take away 12 is -7. Okay? So we now can see that our vertex is the point x equals 2, y equals -7. So 2, -7 is down here. And then we can go ahead and make a table of values, x's and y's. I'll put 2, -7 in the middle of that table. And then we'll plug in 3 and 4 to the right of 2, 1 and 0 to the left of 2. And we plug those values into the function to see what we're going to get for the y values. So, for example, when you plug in x equals 4 into here, 4 take away 2 is 2. 2 squared is 4. 4 times 3 is 12. And 12 minus 7 is 5. So, the y value when x equals 4 is 5. And the y value when x equals 0 will also be 5 because of symmetry. And you do the same thing for x equals 1 and x equals 3. When x equals 1, you get negative 4, and when x equals 3, you get negative 4. And so once we have these points, we can go ahead and graph. So 0, 5 is here, 1, negative 4 is here, 3, negative 4 here, and 4, 5 is up here. And here is our parabola. It's a really tall, kind of thin parabola. Okay? And so, of course, vertex is 2, negative 7. Axis of symmetry is x equals 2. The domain is all real numbers. And the range is all numbers from negative 7 to infinity. Excuse me. Now, again, I am not really too concerned about this. Once people have the vertex and they have the 5 points, this is all relatively easy. The problem is the vertex, which means the problem is completing the square, and a lot of people make mistakes here. So again, the alternative for this is that you can use the formula to find the vertex. And the formula is x equals negative b divided by 2a. And b, of course, is negative 12. And a, of course, is positive 3. And if you do the math here, you get 12 divided by 6, which is 2. So the x-coordinate of the vertex is 2. And the y-coordinate will be f of 2. And f of 2 is 3 times 2 squared minus 12 times 2 plus 5. And this is 3 times 4 minus 24 plus 5. And if you do the math on that, you get negative 7. So the y-coordinate of the vertex is negative 7. Therefore, the vertex is 2, negative 7. And so again, this is just another method. And frankly, it's an easier method, don't you think, for finding the vertex. So when they ask you to complete the square, unfortunately, you are going to have to complete the square. But if you're given the option, you can use this alternative. All right, so that concludes this one.